So in these set of problems, we have a slope field already provided for us. The big challenge is determining which differential equation corresponds to which slope field. Right? So I think the best way to handle this, because I think the next page, I'm going to show you a little graph and calculator shortcut. But for now, the best way to handle it is to think in terms of zero slopes. All right, so ask yourself as you tackle some of these problems, for what values of x or y and/or y, would that be which? Who knows? Values of x and y is dy dx equal to 0. Is your slope equal to 0? Right? It's very easy to lose sight of the fact because, as promised early on in the course, we would be seeing this concept of a derivative so frequently that it just becomes another bit of notation. It's very easy to lose sight of what it's really telling us. It's always telling us the slop of the tangent line. All right, slope of the tangent line, slop of the tangent line. All right, so if I could determine which values of x and y lead to a slope equal to 0, then we'll be in good shape. So one technique I could use would be to set my differential equation equal to 0 and solve. All right, so if I solve this equation, I would be adding y to both sides or subtracting x and negating, but either way, I'm going to end up with y equals x. So what I would want to do is find the differential equation where the zero slopes follow the pattern of y equals x. All right, so zero slopes, or slope equal to 0, follows a pattern of y equals x. All right, so then, if you kind of take a step back and look at it, there's only really one instance where that happens. All right, and that would be this graph right here. So that would be A. All right. Also, you don't want to look a gift horse in the mouth. I don't know what a gift horse is, but you definitely don't want to look it in the mouth, as they say. So, like for example, D, I see cosine of x. I know that the antiderivative of cosine of x is sine of x. So I would be looking for a slope field that seems to follow the pattern of a sine function. All right, so out of all the ones that I see here, I'd be looking at this one down here. So that's the one I would call D. If you want to show the work, there's nothing wrong with that. That's where the stray marks are coming from. Dy would be equal to cosine of x dx. Integrate both sides. By now we know that the integral of 1 dy becomes y, and the integral of cosine of x becomes sine of x plus the integration constant c. Right? That's allowing for all the different possibilities that could exist. All right? So those are a couple of quick examples. So you could use either technique. Set your derivative equal to 0. Most common practice when it comes to, if you're ever in a jam, in a calculus class, what do? Take your derivative, set it equal to 0, and solve. Odds are that's going to be the way to go. All right, and see where that gets you. All right, so I'll leave you to do the rest on your own. The answer key's on my website. If you run into any trouble with the answer key, send me a quick message on Remind, because I always intend to update these things, but sometimes it slips through the cracks. All right. Thank you, and good luck to you.